Hello everyone. So today we will solve a very easy puzzle. Let's look at the question. So the question says that we have 100 light bulbs, right? We have 100 light bulbs and all of these are initially in the off state. Okay. Now what happens is the first person comes and he toggles all the bulbs which are at position that are multiples of 1, right? So the first person will come and he will toggle the state. So if it is off, so the first person will, like, at the beginning all the 100 bulbs are off, so the first person will come and he will actually switch on all these 100 bulbs, right? Then when the second person comes, he will actually toggle, right? He will toggle all those bulbs that are multiples of 2, right? So what he will do is he will switch on, so basically all the 100 bulbs are on now, so he will switch off 50 bulbs, right? Like 2, 4, 6, 8 till 100, right? Then the third person will come, right? So now what will the third person do? If you notice, so now the second bulb is on, the uh, yeah, so okay, sorry, the second bulb is off, the fourth bulb is off, the sixth bulb is off, and the 100 bulb is also off, but the first, third, and all these odd numbered bulbs are on, right? So all those odd numbered bulbs and these even numbered bulbs, so he will only toggle all those bulbs that are multiples of 3, right? So 3 has 33 multiples, till 100. If you look at, there are 33 multiples, out of which 16 are even and 17 are odd, right? Because it starts from 3 and ends at 99, so there are 17 odd multiples and there are 16 even multiples. Now see the odd ones are, they are still on, so all of these will be off now, and the ones that are off now, these even ones, so these will now turn on, right? So basically, net if you see, only one is off, right? So basically now there are 49 bulbs that are on, the rest 51 are off. So this way, if you try seeing till the 100%, this is going to be a very very long problem, so we need to find out the solution. So the question is that, uh, like, when the 100% also does its part, after that how many bulbs are on, right? So if you do it like this, so then I guess you will not be able to reach a solution, because that is a very large, like, the brute force approach is very large, right? So we have to think a much optimized approach, right? Okay. So what you can understand from the question is that let's choose some bulb. Let's say let's choose bulb number 16, right? So can you tell me that how many times will bulb number 16's state be toggled? So initially this was off, right? So how many times will the state of bulb number 16 be toggled? So when the first person comes, he will toggle it. Okay. When the second person comes, he will again toggle it. The third person won't do anything to this. The fourth person will come and he will again toggle it. Now the fifth, 6%, 7% doesn't affect. The 8% comes and again toggles it, right? Okay. Then what happens? Then does uh, the 16% comes and again toggles it. So if you see, 5 times it has been toggled, right? So if it has been toggled 5 times, that means that, uh, like, it was off and the final state would be on, right? If it was toggled for even number of times, then it would still be off, but as it has been toggled for odd number of times, so it will be on, right? Now let's look at another example. Let's look at 32, right? So if you look at 32, first person will come and toggle it, second person will again, fourth one also, eighth one also, 16th one also, and 32th one also. So there are even number of toggles, so the overall state is off. Okay, now let's look at a last example. Let's say I consider 49, right? So see, I'm taking these specific numbers just because of a reason, so that you yourself can draw some inference from it. Okay, so 49, the first person, then the seventh person, then the 49%, right? So there are three toggles, so this also has its final state on. So what can you understand? That for the final state of the bulb to be on, there has to be odd number of toggles, and like, the number of toggles depends on what? The number of toggles depends on the number of devices, right? Now I guess all of you know that any number you pick from 1 to 100, right? Any number you pick from 1 to 100, only the perfect squares, only the perfect squares are the ones that have odd divisors, like odd number of divisors, I'm saying, right? Odd number of divisors. Because any number you take, because, and why, what is the reason behind that? Because always perfect square has this, you know, so unique divisors are always odd because of this particular thing. Like, okay, sorry, this 49, this 49. So because of this particular thing, as there's a repetition, so that's why it's always odd. Because any other number you take that is not a perfect square, for that any divisor you take, let's say you take 3, so there will exist some other unique number that is not this number, right? So p into q, where p is not equal to q, right? This thing doesn't happen. And if this thing doesn't happen, uh, which is a case of a perfect square where p into q, so p is equal to q there, right? So then what happens, this uniqueness increases by plus 1, right? It doesn't increase by plus 2, right? And therefore there are odd number of divisors. So from 1 to 100 there are only 10 perfect squares, right? 1, 4, 9, and then you go to the last one is 81 and then 100, right? So there are these 10 perfect squares. So at the end, like after the 100% is done with this job, only 10 bulbs will be on. So that's your answer. 10 bulbs will be on. Thank you.